Okay. Welcome to forces and force body diagrams. This is just a way of representing the multiple forces that can be acting on a single body or object at the same time. Okay, so FBD, which I will use rather than saying force body diagram all the time, just so you know, that just means this diagram I teach you how to draw in here. So objects move because forces are being applied to them, and there can be more than one force at a time. So sometimes forces point in opposite directions, so we need to know kind of like which force wins out to determine the actual direction the object will move. Okay, so sometimes maybe there's only one force acting and then you know the direction outright, but a lot of times you actually need to kind of combine forces to figure out what the direction is. So just keep in mind, force is a vector, which means we do need to draw an arrow in order to indicate its magnitude and its direction. So longer arrows are bigger forces, shorter arrows are shorter forces. Symbol, we will always label forces with an F, and then we will use a subscript letter like an A or a G to indicate the different types of forces acting on an object. And then just keep in mind the units are newtons. All right, you guys are familiar with pounds because in the United States we use the English system, but a newton is just the metric version of a pound, okay? So, 4 common types of forces that we are going to work in here is the applied force, F sub A, weight, which is F sub G, friction, which is F sub F, and normal force. So let's talk about that. So, applied force. F sub A always points in the direction of the push or pull that you apply to an object. All right, you could be pushing something down. Most commonly, though, the applied force is going to point to the right. All right, we're just going to keep it positive always. So applied forces, draw them to the right, unless, of course, it says it points down or points in a different direction. But most of the time we work with horizontal movement, so the applied force will go to the right. Weight is F sub G, all right? Weight always, always, always points down. It cannot point any other direction. F sub G has to point straight down, all right? And rather than talking about calculating it later, we already know F sub G is your mass times gravity. So mass times 10 meters per second squared. We will use that a lot with free body diagrams, so make sure you remember that. Friction, F sub, you can do FR or you can do just F. The force of friction will always be opposite the motion. All right, so if your applied force is to the right, your frictional force will be to the left. Okay, if you think about it, friction is what, when you roll a ball along the floor, friction slows it down. Friction is going to counteract or work against the motion. All right, so if an object is moving along a flat table to the left, then friction will be shown as to the right. Okay, so that's if I sit there and specifically tell you that the applied force is going to the left. Though normally we will just, to keep the applied force positive, keep it to the right. Okay? So normal force, F sub N. Okay, so usually written as a subscript. It is always perpendicular to the surface and pointing away from the surface. So 99% of the time, F sub N is going to point up. All right? And this ties into Newton's third law, where for every action there's an equal and opposite reaction. The whole reason why, if you're sitting down right now, why you don't fall through your chair is because there is a normal force pushing you back up and keeping you exactly where you are. All right, so counteracting your gravitational force. So in order to have a normal force, you have to have a surface. So say an object is just falling in the air, then there would not be a normal force. But this example, a book sitting flat on a table, the direction of the normal force is going to be up or perpendicular to the table. Okay, That's just a little symbol that means perpendicular if you haven't seen that in math class before. So, force body diagrams. They are always a box, all right? Another thing to keep in mind is that the arrow should always point out of the box, all right? So, you know, the gravitational force has to point down. That shouldn't be pointing at the box. That should be pointing down away from the box. Okay, so real quick, let's label these. Gravitational force, we just talked about that, always points down. So that's our F sub g, which this box, we'll say it's on a surface. So that would imply that we have a normal force pointing up. All right, if we say that there's an applied force and a frictional force, but I don't give you specific directions, I'll always put the applied force to the right, and then the frictional force, obviously counteracting it, to the left. Okay? So let's talk about net force. This little symbol that I drew in here, it didn't show up in the video. This is called sigma, and it just means sum. All right? So in order to find net force, you need to find the net force in the horizontal direction or the x direction. So horizontal is x. And then you also need to find the forces in the y or vertical direction. Okay, this all comes from a grid in math class, x, y. X is horizontal, y is vertical. Okay? So to find net force, we have to add all of our forces together, but we have to separate the horizontal from the vertical. All right? From this point forward in class, we always treat horizontal separate from vertical. Okay? So let's try this a little bit. Here is a free body diagram, or force body diagram, that has 4 forces on there. All right? If you need the practice, go ahead and label the forces. That would be the normal force, this would be our applied force, this would be our gravitational force, and this would be our frictional force. Okay? Now, remember, way back from the beginning of the year when we talked about scalars and vectors, to the right and up are positive, down and to the left are negative. Okay? So in order to add our horizontal forces, we will have positive 5 newtons plus negative 4 newtons, and that's going to equal to 1 newton. Okay? And since it's positive, that also tells us that our box is going to be moving to the right at 1 newton, or with a force of 1 newton, which, if we had more information, could figure out an acceleration. Another thing, again, we also need to figure out our y net force. So again, that's going to be a positive 10 newtons plus a negative 20 newtons, which is equal to negative 10 newtons, which would let us know that the forces actually going down, all right, are negative 10 newtons. So that would actually tell us, I mean, if you really want to get into this with our vectors, that our box here, our object, is moving in that diagonal direction, down and to the right. Don't necessarily need to take it that far, but that's, I mean, this is what these diagrams give you, okay? Practice. So in this one, so our x is going to be, so this would be positive, this would be positive, this would be negative, and that would be negative. So in our x direction, we'll have plus 4 newtons plus negative 4 newtons, which equals 0. All right, and then in our y, we have plus 12 newtons plus negative 12 newtons equals 0. When you get zeros, that means that either the object is, in this case, it means the object's moving, but without acceleration. Okay, so F net equals 0. That means no acceleration. We'll get into a more detailed explanation of that in the next video, but just that's a very, very important thing to remember. So one more example, we have S of x is, let's see, positive, positive, negative, negative. So we have 20 newtons plus negative 5 newtons gives us a positive 15 newtons. And our sum of our y's would be plus 50 newtons plus negative 50 newtons. And that is equal to 0 newtons. All right, in this case, we know that our object is probably sitting on a surface and not moving at all up and down, and it's moving to the right based on the positive 15 newtons horizontally. Okay? This is just some of the stuff that you can get out of these. We will work with this some more in class, but just make sure you have your notes and do the online assignment.